Hey everyone, it's been a while since I posted new content, but I'm back with a fresh Houdini tutorial on how to morph points into a surface and create amazing visual effects. We'll use VOPs, MOP spread, and custom attributes. You'll also discover tips for optimizing your workflow, lighting, texturing, and color grading in Redshift. So let's get started. Here we are inside of Houdini. On the left we have the viewport and on the right the nodes panel. As you can see, I like to keep my nodes organized, and that's why we have 3 categories. Let's dive inside the fiber effects node. First I created a grid, then changed the scale, added the UV mapping just in case maybe we need it later. Next I created a few metal balls with some transform nodes, merged them all together, they look like this, and I use all of those to transform the surface and deform it. Next we have 2 branches. On the left I added a mask from geometry node. We use this mask to create some extra deformation on the initial part of the geometry. We also need to use a subdivide node to have better resolution, and added noise through an attribute VOP. As you can see, if I play this, the mesh is slightly moving. On the right side, I've subdivided the mesh again to have more resolution and scattered a few spheres. Those spheres will be used as starting point for the MOP spread falloff. If we have a look at the spread falloff, you'll see there's a progressive mask animating on the surface. I really recommend downloading MOPs. There's a free version that will help you a lot, especially if you're a Cinema 4D user. Next, I used an attribute transfer to transfer the spread falloff, which I called infection, to the original mesh. And with an attribute VOP, I used a bunch of nodes to create the morphing effect between the points and the surface. And then we cache everything to disk. We are splitting into 2 branches again. One is for the points, the other one is for the surface. They will both be referenced later through these 2 null nodes. Under the FiberFX geometry, there's a small rig which I created to have 2 shortcuts regarding the animation time shift and enabling or disabling frustum optimization. Further to the right are 2 render nodes which I use for redshift rendering, and only these 2 nodes are being rendered. We can also see this in the out context if we go on the redshift ROP, and in the objects tab, as you can see, I have the RNDR underscore and whatever name comes after. This ensures that only the geometry nodes that have this name will be rendered. If we go inside, I referenced from the FiberFX node the points, and I use the time shift for the animation. This is also linked to the rig. Then we have a small transform node, and here again we have a small rig for frustum optimization, but we'll speak about this later when we dive into creating the tutorial. The second node represents the mesh. I referenced the out surface from the FiberFX. Again, I'm using a time shift, the same from the previous rig, and the frustum optimization part. Then I have some other optimization, deleting parts of the mesh and also doing some extra subdivide. Going further, there's a new redshift camera, the optical camera, a null point which I use to focus. It's also animated. And then I have 5 lights, 4 area lights and 1 dome light. In the material context, we have 2 standard materials, Lambert and Chrome, that we use for placing lights and shader development. And then we have 2 materials, the cloth material and the points. For the cloth material, we are using the new styles, which is extremely nice and versatile. And we will be using a point attribute. And as you can see, the diffuse color drives both the cloth material and the points. On the out context, we have a very simple redshift ROP used on advanced mode with motion blur enabled just for the camera, and sampling to 0.09. Let's fire up the render and see how everything looks. I will open the redshift render view and I will select the ROP that I want to render. You can already see the scene is pretty nice. I also used the new redshift optical and LUT controls. If we disable those, we will see some strange color happening on. That's because I created the redshift material with the LUT applied already, but we'll see that when we will dive into the color correction phase. Okay, so let's get started building this scene from scratch. We are in a completely blank Houdini scene. Let's check the frame rate first. I usually use 25 frames per second. Also, we will be using aces as a color space. I'll create a geometry node, name it FiberFX. and jump right in. Let's create a grid. I like to keep my properties panel floating on the right. For now, I'll just keep the normal size. Then let's add a transform. We'll scale this to, let's say, 2.2. I would want it to be a bit longer on the z-axis, so we would add 1.5. In order to keep the same number of divisions on both axes, I'll create a small formula. Here in the roads, we'll need to copy the columns parameter, paste relative reference here, and then multiply by the scale on z-axis. This ensures that whatever columns we have, the grids will be square at all times. Next, let's add a UV project. And I think I would need to have the same scale on both axes, so I'll just copy this parameter and paste the relative reference. Here comes the fun part. The plane is straight and we would like to add a procedural way to deform it. For this I used metal balls with a magnet. So let's first add the magnet, connect it in the first input. I will create a metal ball and I would need, let's say, a radius of 21 with maybe 5 and 6.6. This is how it worked in my example. Yeah, I think I would also add a transform node just to make sure that we can place the metal balls wherever we want. Let's see how it works. I'll just plug in this metal ball to the second input of the magnet. Right now, nothing really happens because I have to change some parameters. On the magnet, there's no transformation being applied right now. So I would need to translate the geometry on y-axis. Let's start with a low number, 0.05. And as you can see, there's a small displacement happening where the metal ball is placed. The metal ball weight is pretty low. So I used 10 in my previous example. The displacement is a lot more pronounced. And I will need to add a few more metal balls in order to create the desired effect. I skipped forward a bit because I had to play with the metal balls to see how the mesh looked properly. So what I did, I basically just duplicated the first metal ball like this and added everything into a merge stop. And right now everything looks like this. So when I plug the merge node into the magnet, you can see that the mesh is being deformed accordingly. Let's just plug in a null here so we don't see those guides anymore. And I think it looks pretty nice. Now that we have our mesh in place, let's start creating the two streams. The left one will have a small noise animation in the front part because there's where the camera will start animating. And the other one will have the MOPs spread fall off mask. I'll create a mask from geometry. This is sort of a new node and it's really helpful. In the second input, I would need a box. Let's reference the initial surface and try moving the box to another position, something like this. And now if we go into the mask from geometry, we see an attribute appearing, which is actually called mask. I changed the radius to something around 10. So then we have a really nice fall off. I can also move the box a bit backwards. And now I believe everything looks pretty nice. In order to deform the mesh, I would need a lot more subdivisions. So let's add the subdivide node. I subdivided the mesh 5 times. I know this can be pretty high, but for the noise deformation, we really need this. And also for rendering out the displacement and everything. This is how it looks right now. In order to deform the surface, I would need to add a point VOP. Let's dive inside. First, I want to bring the mask parameter here, so I will use a bind node. This node imports external parameters. Here I need to input the mask, and if I want to check if this is working, I can just connect the mask to the CD. Now we see the mask is being displayed in black and white. Let's use an anti-aliased flow noise. We'll plug the position first, create an add node, add the original position together with the new noise position and move that into the output position of the VOP. If we zoom in, we see there's a lot happening here, but we would need to have all axes, not just one. So going into anti-aliased flow noise, we will need 3D input and 3D noise. There's a lot more things happening here because we use all the axes. In order to have some movement, we need to animate the flow, but we can do that either by bringing a parameter or by exposing this parameter outside of the VOP net. This time, let's expose the parameter. I can just middle click and hit promote parameter. I'll promote more of those because I would need to further adjust them afterwards. Okay, going back, now there's a lot more parameters happening here in the attribute VOP. We can start tweaking those. Of course, I can change the frequency to something like this. Then I will change the amplitude a bit. And I can also distort it more on one axis, for example, have it more elongated on the X. So now it looks more like a cloth surface. I can also tweak the roughness a bit. Okay, let's leave it like this for now. In order for the noise to be animated, I would need to use the time of the scene to add the flow. I can use the variable at time. And now if we scroll up to the timeline, we see that the surface is moving. Of course, right now it's a bit fast to my opinion, so we would need to multiply this by 0.5. And now it's a lot slower. We will further tweak these parameters after we add the camera and everything. In order to have this noise moving only where the mask is applied, I will need to go again inside the attribute VOP and create a mix node. We will connect the initial position, then we'll connect the new position, and as a bias, we'll connect the noise mask. And now everything will go into the final deformation of the mesh. Oh, for now we don't need the color anymore, so we can just erase the node. And now we see that the noise only applies where the mask was. Of course, we can still tweak the box position. So I think it would need to be somewhere around here. And let's increase the frequency a bit more. Something like that. Before moving further, let's create the second stream where we will use the MOP spread falloff to create a mask over the geometry. I need to use another subdivide SOP. I think I used the 4 subdivision here, and let's check the mesh. Yeah, it looks pretty nice. Next, add the MOP spread falloff. By default, the node doesn't do anything because we need to specify where the mask should start from. In order to do that, I would need to create some sort of point cloud or having some spheres copied to some points. Let's add a scatter. With the scatter node, there will be a bunch of points scattered over our surface. I would like to reduce those maybe to 20, and let's try to change a bit the global seeds somewhere around here. Of course, we can template the mesh so we also see where the points are located, and I think we're pretty fine as we're interested more in this area. Let's create a sphere, check the subdivisions, we'll change the type to polygon and add like 100 frequency. Maybe it's too much, let's say 70. And now I would like to scale down the sphere. So let's add the transform and scale it down in a uniform manner at 0.2. Then I need to add a copy to points. So I plug in the spheres and the point cloud. And now if I view the copy to points, you'll see there are a bunch of spheres copied over our points. And then, of course, we would need to plug the copy to points to the MOP spread falloff. In order to see what the spread falloff node is doing, we need to enable preview falloff, but nothing's really happening. And that's because we need to change the start point mode to point cloud. To see the preview, we will go in the animate tab and let's try to change the spread. So there's a really nice spread happening over our mesh. Of course, I will still need to tweak some parameters, but at least we have a starting point. Let's create 2 keyframes. One will be on frame 1, so the spread will be 0. And I think if we use frame 200 as a reference point, that will work for us. Going to frame 200 and the spread should be around 1.25, I would say. Add the keyframe here and let's play the animation. Very straightforward mask infection. The edges are kind of bothering me, so I would like them to be more scattered and have a noise pattern. In order to do that, I would need to apply a noise, and I think purling noise is fine for now. Maybe change the frequency, let's see, to something to 0.9, and it breaks a bit that edge here. Let's transfer the MOPs falloff onto the original mesh. For this, I will use an attribute transfer. In the second input, I will plug in the MOP spread falloff, and here I will select only the MOPs falloff. So we don't want to copy all the attributes from the right stream, we just want to copy the MOPs falloff, and I'll disable the primitive just for safety. I probably would like to increase the maximum sample count, but let's see how the transfer looks like. In order to do that, I can drop a MOPs preview falloff. This one allows me to view the MOPs falloff again. If we zoom in, we can see there's some strange interpolation happening on, and for that I would increase the maximum sample count. Now everything has more samples and it's smoother. Next we will drop a point VOP. Inside of this attribute VOP, we'll intensively use the MOPs falloff attribute to distort the geometry. Inside there are two nodes. One is the input of different parameters and the other one is the output. We will need to bring the MOPs falloff attribute inside of here. So for that we will use the bind node, and let's write MOPs falloff. To check if this is working, I would need to add this to the CD first and just scrub to the timeline. Oops, I misspelled. It's a really good idea to check your attributes before working with them. So it will be like this, MOPs falloff. And now it's working. In order to do the morphing, I would need a bunch of things. One would be to distort the surface and create like a wave ripple effect. And the other important aspect would be to add an alpha where the mask is black. Let's do that first. Bind export. With this node we can export parameters, and if I export the MOPs falloff as an alpha, I just need to write here alpha. You can see already that Houdini tries to illustrate the alpha in the viewport, so that's a really nice feature. Probably I would need to have further control over this, so I would add a ramp parameter, change this to a spline ramp, and let's go back. Here Houdini added a ramp for us. Everything is black right now, so I need to put the second node on default. Going back inside, we can rename this to alpha, and now let's do the other magic. In order to move the edges of the geometry, I would need to add a displace along normal node. Drop it here. First, it will need the position, so we plug in position to position, and then the displace position would be exported to the new position of the geometry. So let's cut the CD for now because we don't need it anymore. Of course, nothing really happens because we need to specify a scale and probably an amount. For that, we will need to add some extra nodes around here. I think the amount would be actually the MOPs falloff itself with some ramp over it. First, let's just connect the MOPs falloff to the amount and let's see what happens. There's some interesting stuff going on. Let's disable the alpha for now. In order to tweak this, I would need to add another ramp. So let's add a ramp parameter. Plug into here, name it displacement ramp or just displacement, and put this to a spline ramp again. And let's try to create something out of it. If the noise pattern is a bit distracting, we can just disable this for now, so we focus on the surface itself. My goal here is to create two waveforms. One of it would be more subtle and the other one will be more abrupt. In order to do that, I will need to tweak a lot the displacement ramp. I will just add one knob here and move the other one to the 0 position. As you already see, I kind of created a first wave, but the interpolation is a bit hard, so I will change all the knobs to monotone cubic. And as you can see, the waves are a lot smoother. Let's tweak further these knobs here. After some tweaking, I managed to create two wave patterns and I think they look pretty good. Before moving forward, I would like to take a moment and show you my new website that I'm currently working on. You can navigate to the Learn page where you'll find all the tutorials that I have published. If you scroll down, there's a subscribe form for the upcoming newsletter. I promise that I'll make sure to keep you up to date with every new tutorial and assets that I release. Back to tweaking the nodes. I would like to have more control over the height and also maybe add some extra deformation on the edges of the infection or the surface. In order to do that, I would go inside the point VOP again. Let's add more nodes. Just for safety, I'll connect the normal to the normal input of the displacement. I would like to add an anti-aliased noise that will affect the edges of the surface. The anti-aliased noise, it's a bit special because we can add a 4D input and export a 3D noise. Let's do that. I'll switch to 4D input and 3D noise. The 4D refers to time as well. In order to have a 4D input, we will need to add the time to the position. Let's add a vector to vector 4 and connect it to the position of the anti-aliased noise. The vector would be the original position of the surface and the fourth value, the time. We will connect the time to the fourth value and the noise to the scale. Of course, there are a lot of parameters that need to be tweaked. Expose some of of them here, as we did before. We'll promote frequency, offset, amplitude, roughness, and noise type. To have more control over our time, I will add a parameter and multiply it with the time. Add a multiply and the parameter here. I want to change its name to time multiplier, time mult. This takes the initial time and multiplies it with a value. Let's jump back and adjust some parameters. The interface got a lot more interesting, and firstly I will address the time. Let's add this to 1 to see what the noise is doing. I can add a time shift, delete the channel. That means that the infection or the spread doesn't work anymore, but we'll see what's happening to the flow noise. I think the speed is right. Maybe let's dial it down a bit, 0.8. In order to control the height of the mesh, we would need to add a fit range to the anti-aliased noise. Let's dive inside the point VOP. Right after the noise, we'll add a fit range and plug it here. Next, let's promote the parameters, and going back, we tweak the minimum value. You will see that the height is starting to grow again, and this would be actually the representation of the noise. If I play the timeline, we see what the noise is actually doing to the mesh. I think it adds a pretty nice variation while the MOP spread will move with the surface. In my previous example, I had 0.3 here and around 3 on this one. Before moving forward, I'll do a double check on the parameters because I feel that the surface here is a bit too rough. I'll just move the roughness to around 0.27, and let's also change the time multiplier to 0.5. I will also change the frequency to something like 0.5. Let's try in between 0.56. Yeah, something like that. Let's not forget about the noise that we added in the first place. If we enable this one, things will get a bit funky because the amplitude is a bit too high right now. So let's see how we can dial this. Let's tone down the roughness as well, and maybe also the amplitude. I will further tone down the roughness and change a bit the frequency on X. I'll create a play blast. Before that, don't forget to disable the time shift because we don't need it anymore. The play blast is ready, and let's see how it looks. Hey, pretty neat. Before finishing with the point VOP, I would just like to make sure that I enable alpha again. And to organize things, we can edit the interface a bit here. Let's drag a folder, name it alpha. I like to use collapsible, especially in the new interface. I'll drag the alpha here, then drag another folder. We can call it displacement, and drag the displacement ramp. Add another folder inside just to keep everything really organized. And we can use a simple folder here. Let's select everything that has to do with the noise. We drag them into the folder, hit apply. I think I need to make the displacement collapsible as well, and make sure that the noise is inside of displacement. Then we still have to organize those 3 values here. I'll add another folder, name it scale. We will drag minimum and maximum values, make it a simple folder, hit apply, and we have noise, scale, and the displacement ramp. Further down we have the time multiplier. We can just add a spacer for that one. Let's make sure both are in the displacement folder. If we hit apply, we have a very nice interface where there's a tab with alpha, another tab with displacement, and all the parameters here. It's time to cache everything to disk. For that, let's add a file cache. I like to use the old way of caching, which is the explicit path. I can see exactly how the file is being named and where it will be saved. I would like to replace the heap name with $OS. And add a slash. This means that the cache files will be saved in the geo folder. It will have another subfolder with the name of this node, the name of the file, the sequence, which will be in 3 digits, and the extension. Let's rename the node surface cache and change the frame range from 1 to 175. Before caching to disk, I would like to check my attributes so we don't save unused data that takes space on our drive. I have here the mask, which I really don't need. This was only for the initial noise, so I would add an attribute delete, and on the point attributes I can search for mask. Now let's start the caching process. Caching is done and the files are loading from disk. Okay, nice. Before moving forward, let's organize a bit the nodes. I always advise you to organize your nodes, because if you open the file after a period of time, you'll have difficulties to understand what you did there. Moving forward, let's add another null here. We'll create two streams. One will be the points and the other one would be the surface. Again, two nulls. The left one will be out points and the right one out surface. For the surface, I would like to delete parts of the mesh because we won't see it in the render. If we look from the side, the camera will be around here, and here's like a hill, and we won't see anything after that hill. That's why I would advise to delete this area. To do that, we'll add a delete SOP, set it to points and to bounding volume. We can move it backwards and scale it up. This will be really helpful for our render times later. In order to create the points, I will add an add SOP and activate delete geometry but keep the points. So now the surface is deleted, but the points are still there. If we have a look at the attributes, we have alpha, MOPs fall off, position, and UV. We don't need the alpha for the points, so let's go and delete that. Now I would want to scale the points based on the MOPs fall off. We can do that with a point wrangle and a few lines of code. Let's add a point wrangle. We want to create a float value. Let's say float faction equals to fit01 float at MOPs from 1 to 0. Why I change from 1 to 0 is that I want actually the MOPs fall off to be inverted. Of course, I have a typo here. Let's create the p-scale at p-scale equals to channel float, and then we multiply that by the infection. Of course, you can name infection whatever you like. If we hit this button, you see there's a new slider created for us. For extra optimization, I would like to delete some points if they are very, very small. So let's say if at p-scale is lower than 0.001, then we remove the point. Everything is gone because the p-scale is 0. We would need to display the points as disks to see how big the p-scale is. So if we go to geometry, we can display the points as disks, for example. This helps us to have a better understanding on the scale. And for my example, I think I used something really low like 0.045, and already it starts to look like something. If we also template the out surface, you can see they kind of blend pretty naturally here. Part 2 of this tutorial will be released in a couple of days. In the meantime, you can subscribe to my channel so you don't miss any updates. See you soon!